Hello interwebs, welcome to Let's Fix Computers. I've got a MacBook Air A23, what was it again? An A2337. Yeah, so I'm fairly certain this one's a MacBook Air M1 with no power. There's no reports of liquid damage with this one, so I'm going to plug in a USB cable and we'll see what it's doing. So when we plug in a Type-C cable, we're sitting at 5 volts and pulling 17, 18 milliamps, which is functionally zilch. And I'll just try the other port. Yeah, same deal, basically nothing. So it's not negotiating 20 volts and it doesn't appear to be doing anything. So let's take the back cover off of this and see if we can spot anything screamingly wrong inside it. Got to wrestle off this hard cover first. I don't like these hard covers. They're a pain in the ass and they just trap dirt and grit on the inside. So even though this thing has been in a cover, the case is okay, that's coming off, but over time it develops all these little pock marks in the soft aluminium where the grit digs into the metal. So like, I guess this might defend the laptop from being knocked on a door handle as you walk out of the room or something, but I don't think these actually provide meaningful protection personally. I think a laptop is better off being used just naked and then put it into a soft case when you're taking it somewhere, because a soft case is actually going to absorb a blow. Right. Not much to see in this one. This is one of the ones where you've just got a metal plate. So the logic board does actually extend all the way back to like here. It's not literally that. It does extend under here. That's the CPU cold plate, basically. These things run such a low wattage that they just don't bother putting a fan in it at all. Looks like something's up with the pull tab on this connector here. Disconnect the battery. Not super familiar with this board, so I'm just going to poke at random a little bit just to see if I spot anything screamingly obvious. So let's just punch down on the digital zoom and I'll put the multimeter into resistance mode, and I'm just going to stab wildly at some of these capacitors and just see if anything pops up. Right, that's ground. Oh, okay. Well, I've just gone straight onto this tantalum capacitor and that's shorted. I think I think this side I'm on is meant to be hot because that's 0.3 ohms, and if I go to the other side, we get 0.04. So that must be true ground. There should be a positive symbol on it, but I can't see it in the lighting. Let's just check this one up here as well. 0.3, 0.06, yeah. Alright, so yeah, we've got a big short circuit in this thing. I don't know what rail that is, but yeah, just straight away, just poking at tantalums, we're seeing a short. Let's pull the motherboard out of this. This video is sponsored by me because I'm selling merch now. You can go to adamantIT.co.uk/store and peruse my fourth wall shop for such bangers as the Adamant IT hoodie. It's got a logo on the front and on the back, and it comes in many colours, and it's super comfy. You can also get this design on a t-shirt like this one, or even this one. There are plans for more designs, but it took me a year to get this far, so I thought I'd better launch with what I've got for the time being. If clothing isn't your cup of tea, you can buy a cup for your tea, like this one. It's got the logo on the one side, and it's got me doing an impression of Dean from the Iron Giant on the other. There's also a full logo version, all available in various colours. For these things and more, check out adamantIT.co.uk/store or click the link in the description. And also give me other merch ideas in the comments if you fancy. Now on with the video. Almost seems like there's just a little bit of residue on the bottom of the board here. I think maybe this has had a liquid spill, but there's no big giveaways though. There's just little bits here and there that make me go, Okay, let's move the body out of the way for a sec. With the motherboard out of the laptop, we are no longer shorted. Okay. So our problem is with something that is plugged into the laptop. This is why it can be important. This is a good lesson in why sometimes doing those initial stabs when you've just taken the cover of the laptop off can be incredibly valuable, because what we've just confirmed is that whatever the fault is, it's in something else here. So immediately I'm suspecting this connector that looks like it's seen some heat. Obviously we could have like the trackpad and stuff like that. Also big suspect over here on this secondary board. That could be our issue as well. Let's do some more poking. I can't easily measure what these connectors are over here, but I'm going to quickly stab these capacitors and see if any of them are shorted. Yeah, that looks like a short to me. Let's find an actual screw hole and just for a better stab. Yeah, it's this guy up here. It's the soundboard. All right, let's get that fella out. Come on, don't make me take the speaker out. I don't want to. There we go. Let's take a look at this under the microscope. Right, so all of those caps kind of look like they've got like pock marks in them, because like that looks like it's sort of got a bit of a knock in it, but they kind of all look like that, so I don't think that's anything super significant. That capacitor just looks a randomly different color to the others, but you know, it might be a different value. This is conformal coating, what you're seeing here, so that's not a puddle. Weirdly, they decided to conformal coat this side of the board, but not the other. And then we've got the headphone jack here. So this is all audio. And these capacitors are here most likely as bypassing for the speaker amplifier. I think that's a speaker amplifier because this is the speaker connector. Alright, so we could just buy another one of these on eBay, but also what I might do is just immediately stab this with some power injection and just see what lights up. Right, we're under my Infrared P2 Pro thermal camera here. So I've got the circuit board with a ground crocodile clip clamped onto one of the screw holes. And then behind my red probe here, I've got 1 volt and 3 amps from my DC bench supply. So I'm going to touch that against the positive connection of one of those tantalum capacitors, and we'll see which one of them lights up. So here we go. And the answer is none of them. It's one of the ceramics in the top left. Okay. Right. Fair enough. All right, let's jump back under the microscope and we'll take a closer look at that. So it was this chap here in the top left. That one was lighting up under the thermal camera. And again, this is bypass capacitors that are feeding into this speaker amplifier. So this guy is shorted to ground. It's just a wire going straight through onto this ground plane around the outside. That's where all of our power is going. So that's probably on a significant power rail. I'm guessing it's on the 5-volt rail. I think that's going to be. I don't think that's going to be on PPBus G3 Hot. This I/O board that we're looking at, this I/O board for the audio and also the Touch ID fingerprint sensor plugs in there. I don't think this is going to be on the schematic, but let's take a look and see what we can find. The actual board itself is an 820-02016, so let me just open up the schematics for that. Here we are on the board view, and as I suspected, having a look in the schematic and on the board view, it looks like the I/O board or the audio board isn't on these drawings. However, we can use the left side speaker as a reference here. So what I'm looking at here is the left side speaker amplifier, and if we drill down on the logic board where that is, that guy is here. So this is our left side speaker amplifier, and up here it's got a little row of 4 ceramic capacitors, just like the right side speaker amplifier. So we can use this as a reference because although this is laid out slightly differently, the actual design is the same. We've got the same bypassing on it, so we can use this as our reference point. If we look at CR608, 5, 6, and 7, that is these guys here, 5, 6, 7, and 8. That is on PP bus A on L speaker amp. And what rail is that powered from? Let's just check. If we have a look where the power for these is coming from, it's coming in through this diode here. That becomes PP bus AON. Oh, there we go. There's the capacitor. That's the first capacitor that I measured when I was looking at it. So yeah, this is basically our main power rail then. And these are the big capacitors that I was measuring at the very beginning of the video and going, oh, look, there's our short. So these capacitors were shorted because through the speaker amplifiers, they are connected to the subboard, which goes through to a shorted capacitor. So these capacitors are all 10 microfarad 0603 ceramic capacitors. So over here, this little bank of ceramics here, this will be connected to PP bus AON R speaker amp, right speaker amplifier, which in turn connects back to the main power rail. So that's why we're shorted. So we've got to take that one in the top left off and replace it with another. Will I be able to fit on this 0803? Yeah, it's a little bit chubby, but that will fit. Cool. Right, I'm going to warm up my hot tweezers for that. I really need a small PCB clamp. I've got one at home, but I don't have one in the shop. Just feed some fresh solder onto there just to wet the joins. Oh, this thing's going to move around all over the place. This is going to be really terrible. Oh, there we go. And replacement. I'm going to add some flux for the replacement, just to help that flow straight. Oh no, that's way too much. I'm going to make a heckin' mess everywhere now. Trying not to knock off those smaller components just below where I'm working. There we go. Right, I think that's on. Now, alcohol and toothbrush. There, that'll do it. Let's just double check that this is no longer shorted. So I'll turn it around. I'm just going to measure across these tantalum capacitors again, because we know that those were previously shorted. Yeah, and we're seeing 20 kilo ohms and rising there. And the resistance is skyrocketing and then settling because as the capacitor charges, the capacitors on this rail are initially low resistance, and then as the multimeter feeds current into them, they charge up and become high resistance. So that's why it takes a while for the multimeter to settle when we're measuring a heavy rail like this, because there's a lot of capacitance on that rail that will charge and change as we're measuring. We could have bought another one of these audio boards. They're probably like 10, 15 pounds on eBay. Then it wouldn't be expensive, whatever the price is. But as you can see in this instance, I've managed to A, save a little bit of money, which means the money that I would have spent on a new board now becomes more profit for me. And B, it means I was able to fix this laptop right here, right now, instead of having to wait for parts, and that's always nice as well. I'm still curious about that kind of weird residue that we've seen all across this laptop. It really feels like it's seen some liquid at some point, but none of that seems to be causing any meaningful harm, so I'm not gonna read too far into it. That's everything hooked up. The battery is probably going to be flat because while this would have been sitting on the shelf with a short circuit in it, the battery would have been just like constantly trying to power up, constantly, and being just switched on and off over and over again forever until the battery reaches stone flat. So let's plug in a USB cable and see what we get. Okay, it chimed. So the laptop just turned on, and as you can see, we're getting 20 volts and half an amp, which is just shot up to about 1 amp. It's jumping around at the minute while it decides what it's doing. Let's open it up. There we go, folks. Look at that good boy. What a good boy. All right. Clock is reset because the battery's been disconnected. But yeah, it's good. All right. That's it, everyone. It was a shorted capacitor on the audio board, or I/O board, whatever you want to call it. Could have bought one on eBay, but in this instance, we replaced the dead capacitor, and this thing is now A-OK. Thank you, everyone, for tuning in, and I'll see you next time. Bye.